Hello everyone. In this video, I am going to talk about section 3.4, three-dimensional force systems. In the past section, past PowerPoint, we talk about all the what's going on in the 2D world. In this one, we are going to look at some forces in the 3D world. So whenever a particle is in equilibrium, vector summation in 2D system, we talk about summation of force equal to zero. So you have summation of the forces horizontally, x direction equal to zero, and summation of the forces vertically along the y direction equal to zero. Now in our 3D world, we're going to add the k component along the z direction. So you have sigma f equal to zero, meaning sigma fx equal to zero along the I direction, plus sigma fy equal to zero along the j direction, and also sigma fz equal to zero along the k direction. These equations are the three scalar equations of equilibrium. They're valid for any point in equilibrium and allow you to solve for up to three unknowns. In the 2D world, it's always two equations and two unknowns. In the 3D equilibrium system, we can solve for three equations with three unknowns. Example number one, we have three cables, CA, DA, BA, that is pulling this particle A, and you have a weight 300 pounds coming down. Okay, we're looking for the tension in the cable AB, AC, and AD. We're going to first draw free body diagram, just like in the 2D world. So we have three forces acting on particle A. So what's going on here is that just like the 2D world, we're going to need to break down all forces into the IJK or the XY component. Starting with B. B is actually one of the easiest because B is along the x-axis. Look, B is along the x-axis. Imagine the YZ plane is your screen, and then the x axis is coming out of the paper, coming out of the screen. Okay, so B, vector B, tension B is coming out of the paper along the x-axis. So you have TB, which is only the I component. TB will only have the I component. There's no Z or Y component because it's on the x-axis. Now the C component gets slightly more complicated, okay, but we'll take a look. C component, we're going to project it twice. Number one, I will project the C to right here. That gives me the C prime. I project the TC into the XY plane. The one that I just drew is going, XY plane where you have a negative X value and positive Y value. So in this purple triangle, I'm going to highlight in this purple triangle, if you really put it in the 2D, 90 degree is right there. So if you want to put it in the 2D, TC is right there. And you have TC prime projected. So TC prime projected is this one down here. And I know that this angle is 90 degree. Okay. And then the vertical one, which is this one, same as this one, that is going to be your TZ. And not TCZ or C, let's put a notation correctly. Let's call that T. Let's call that TCZ. Okay. And then this is TC prime. TC prime based on our trig function, that will be TC cosine 60. And then the TCZ will be TC sine 60. Keep going. I'm going to change to a different color, the green one. I'll break that TC prime into the X component, which is the green that I drew, and then the Y component. Now, if you put that in the 2D world, in this green triangle, the green one right here, you have your TC prime as the diagonal, and I'm breaking that into your TCY and your TCX. And be careful, positive X coming out of the paper, coming out of your screen, and then that means this X over here is on the negative direction. Okay, so you have a negative value for your TCX. So overall, your TCX is going to be, this angle is, I couldn't tell. Hold on, I need to get rid of my drawing here. What angle is that? I think over here says 30 degree. Okay, so 30 degrees. So TCX 30 degree, it will be TC prime cosine 30. Cosine 30 gives me the Y, okay, because this is 30. and then your TCX is negative TC prime sine 30. And then over here, I am going to plug in the TC prime into plugging the purple to the green here. That will give me another set of equation, which says TC, so this one, in this one, I am going to plug in with this one right here. So that will give you the equation over here, meaning your TCX is going to be negative TC prime, which is TC cosine 60 times cosine 30. Okay, and then your TCY is going to be TC prime, which is TC cosine 60 times sine 30. Okay, and then your TCZ, we got it on our very first step, which is this one right here. That's TC sine 60. Okay, so that's what's going on in this portion. We break it, project it twice because it's in the 3D world. Next one, and then you plug into your calculator. Next one is your TD. TD is all the angles are given. So you're going to use that 120, 45 degree, and the 60 cosine, cosine, cosine to get the actual IJK component. And I'll be careful with the direction. Again, sort of coming out of paper, so you'll have a negative x value. You have a negative x value, but that cosine 120 should take care of it. Cosine 120 should automatically give you a negative value. And then for the y component, because it's going toward the left, look, cosine 120, it still gives you a negative value because it's going toward the negative, what is it called? Negative direction of the y-axis. And then also the k direction, I'm going up. It's cosine 45 going up, positive value. Okay. And then the weight is negative 300k, meaning I'm coming down, going the opposite direction of the positive z. So putting that together, I have my IJK. Okay, so what we're doing next is put all the I component together, set that equal to 0, because it's in equilibrium, meaning sigma fx equal to 0, sigma fy equal to 0, and sigma fz equal to 0. So what it means is that over here, let me clean that page. Let me clean my page. Over here, what you're looking for is that you are going to put this I, all the I, that one, and that one together, all the I, TB minus TC cosine 60 sine 30, and then minus 0.25. Add that together. Oh, I missed the D. So you also need this one as well. So this one here should be, yeah, sorry. So TB, TC component, and the TD, the I component, all of their I component go together. And then your J will be, here's your J number 1 from the C, here's your J number 2 from the D, and then that's it. Okay. And then for your K, you're going to put that one plus that one plus that one, or these three. So we got 3 equations and 3 unknowns. There's your equation for your the Z, which is the last one that I circle, which is the red one. I'm putting all the color coded. This is the red one. And then the purple one is the J, which is your K. That's that one. Okay. And then for the next screen, next slide, you have the I, which is the green. I is your X. I, J, K. Okay, hope that helps you. 3 equations and 3 unknowns. We're solving for TC, TD, and TB. Example number 2, very similarly, we're going to draw the free body diagram about point A. Okay, 3 cables, AD, AC, and AB supporting point A, and you have a weight pulling down. We want to find the forces. So every single one of the forces, we're going to break it into the IJK component. FB is on the XY plane. One more time, FB is on the XY plane. That means when I break that FB into the X component and the Y component, you will have the cosine 30 gives you, because 30 degree is right here, cosine 30 gives you the J component, along the Y direction. So this is your FBY, and that one is your FBX. Okay, so you have your X component and the Y component, and then the C is along the negative direction on the x-axis, negative direction. So because positive is over here for your x. CFC is along the negative direction of your fx. That's why you have a negative c. And then for the value FD, this is back in when we talk about position vector. So for your point A, because it's at the origin, point A is 0, 0, 0. Point D, the coordinate, this one right here, I'm calling it point D right there. The coordinate for that point D, x value is 1 meter positive, 1 meter toward the positive direction of x. And then your y is going to be negative 2, 2 units, 2 meters away from the going toward the negative direction of y. And then your z component is 2 meter, that's positive, okay? So you have 0, 0, 0 for your A, 1, negative 2, and 2 for your D. So position vector RAD, remember we say ending point minus the starting point, right? Ending point, let me put it down here. Ending point minus the starting point. So you have the D minus the A. So that gives you 1I. D minus A for the J will be negative 2J. And then D minus A for your K, 2 minus 0. That gives you plus 2K. Okay, so that's where that comes from. Divided by its magnitude. Magnitude says you have, this is RAB, this is RAB on the magnitude. So this is 1 square plus 2 square plus another 2 square. That's what this part is, okay? Position vector divided by its own magnitude, that will give me the that will give me that will give me the unit vector of that position vector, and then multiply by the FD, which we don't know what that is. So I put my unknown, I carry my unknown FD in there with it. That gives me the IJK component of that FD. Now putting all the I component, will giving you the equation for Fx, putting all the J component, giving you the equation for Fy, and putting all the K component, giving you the equation for Fz. Set them equal to 0, 3 equations and 3 unknowns. All right. Next group problem, same thing. Looking at this, I know it's giving me a lot of dimensions. I know that I can use them to calculate the position vector. I can use the coordinate to find the position vector and then carry the unknown in there, 3 equations and 3 unknowns. So over here, my A coordinate A is going to be 0, 6, and 2.5. And then position B coordinate is going to be negative 2, 0, and 4. In position C, I have 2, 0, and 5.5. Okay, so ABC. Position vector, so you have the ending point minus the starting point. I'm going to show you just one of them as an example. AB, that will be the ending point B minus the A. So you have negative 2 minus 0, that will be negative 2I. B ending point B minus A on the J component, 0 minus 6, that will give me negative 6J. And then 4 minus 2.5, that will give me positive 1.5. Right? B minus A. Well, is that right? Yeah, 4 minus 2.5. Just double checking. Okay, yeah, we got it. So that will be the K component. That is the position vector. And then we're going to do the divided by the magnitude, AB. Let me put magnitude over here. Magnitude is going to have square root of 2 square plus 6 square plus 1.5 square. It does look a little different than this, but trust me, you go simplify it, it will look just